Okay, moving on to 15.8, which is applications of logarithms and exponential functions. This is our last section for intermediate algebra. We have about 14 problems to do. I'm going to try to do 2 or 3 in each of these videos. So number 1 is something we've seen before. It's a compound continuous interest formula. And so here's our compound continuous interest formula here. And on problem number 1, they give us the money, okay? So this represents the money, and then they give us the rate as 12%. And we change that to the decimal, and then this is the years. Okay, and then we just put that in, and we use our calculator here. So that one's similar to something we saw in 15.3, and then we round our answer. So this 18,000 grows to $21,549 roughly. Okay. Now this problem is a little different than this one because if you see here that we're going to have to solve for the number of years that $10,000 is going to grow to $20,000. So what we want to do here is one method we can use, and on your note sheet you'll see a couple of methods, but we can divide by 10,000, and what we get is 2 is equal to e to the 0.045 t. Okay, and then one method here is we could say, hey, this is in exponential form. Let's change it to logarithm form. Okay, so we could say log base e. Now we know that's going to be replaced with ln. The exponent part's going to shift over to this side, so we have 0.045 t, and the 2 is going to shift to this side. So we have ln of 2, the natural log of 2 is 0.045 t. And then this should look familiar. We just divide by 0.045 and divide by 0.045. So what we do then is type this into our calculator. And we come up with approximately t is approximately 15.40 years. So the money would double, $10,000 to $20,000 in about 15 years. Okay. Then on this one, we're going to look at a slightly different way. You'll see it's similar to this problem. We have to solve for the years again. All right, that's what we're solving for. So we're going to divide by 7,000 to get started here. Okay. When you divide by 7,000, we get 25. We can cross out these zeros here. We get 25 over 7 is equal to e to the 0.06 t. Okay, and then showing a slightly different method on this one. What we can do is we can take the natural log of this side and the natural log of this side. Very similar to this one. We'll get this, we'll cross out, cancel out the natural log of e, because that's 1. Okay, and then we have 25 over 7 equals 0.06 t. And then we'll divide by, oops, forgot my ln here. Divide by 0.06, divide by 0.06, and we get t is approximately 21.22 years. Okay. So you see slightly varying methods here. Hopefully you can practice both of those and get familiar with both of those. So that's 3 application problems. We'll move on and look at a few more.